Okay, we're going to do two things now. One is we're going to look at the same Holt-Winters model, that is smoothing all the three series, the trend, the local, the trend, and the seasonality. But now this time we're going to use multiplicative model. Okay, and the second thing is we're going to take a larger data set and we will do all three. So we are going to do an additive model like we did before. We do a multiplicative model, and we are also going to do a transformation like we have done in chapter 2 and 3. We'll do a transformation of the original data and apply the Holt-Winters multiplicative model for that. So one additive model again, and then two multiplicative models. And when you have multiplicative models, again we have L sub t, T sub t, S sub t. Now remember, in multiplicative model, after you add the local value and the trend, in the additive model we added the smoothed seasonal index. Now we're going to be multiplying. Okay, and these are the formulas like we have seen before. This is for multiplicative model, and then the starting values. The starting values for T and L are the same, but for seasonality, since this is multiplicative, so instead of a minus we have a division. That's the difference in starting values. Same is the case here also. Whenever instead of having addition or subtraction, you have multiplication or division, except that for seasonality is slightly different. Okay, now let's go to the Excel file and let's set up the initial values and the model. Okay, so here the data file is autos quarterly. Okay, and here we have lots of observations, 164 of them. So we're going to split this up into two. One model for estimation, the fitting sample will be from 1996 through 1999, and the holdout sample is 2000 through the end, which is 2006. Okay, so well, let's make up some trial values, and here there are 4 quarters. Okay, all of this would be very similar if you have 12 seasons or 5 seasons or 16 seasons, 52 seasons. It doesn't really matter. You have to be consistent, that's all. So the initial setup is what is you need to be careful. Once you set the initial setup correctly, and then all you have to do is to copy it for the rest of the data set. Okay, so now the initial value, we start with T sub t. So here we average the second full cycle minus the average of the first full cycle. Okay. Now, so that would be how much trend has increased by for one full cycle. Okay. Now we have to divide that by the number of cycles. So we need parentheses around this, and then we divide by m. Okay, so that will give us the initial value for trend. Okay, now for the local value, you average that puts it at the center, plus you have to go m minus 1 over 2, okay, times the trend. Seasonality is you take the actual value of the quarter from the first year, first cycle, and the second cycle. Okay, so divide by 2. So that's the average of quarter ones, 2 quarter ones. Then you subtract from that the average value over 2 entire cycles. And you need to make sure that the first 2 full cycles are absolute referenced. Okay, and then we copy that. Up to this point is exactly same as what we did previously. Okay, now that we have set the initial values up, let's do the forecasting. So the first forecast is going to be, so this is additive model. You're going to be doing multiplicative model in just a little bit. So these two plus the seasonal factor. So the error is the auto sales minus the forecast. So all of this is exactly same as what we did previously. Okay, let's set up the smoothing. So smoothing for L is the previous L and T, sum of L and T, plus alpha, absolute reference that, times the error. Now for T, it is previous T plus beta, absolute reference that, times the L that we just computed minus the L and the T from the previous period. Seasonal index, go back all the way to the same season in the previous cycle, plus gamma, absolute reference that, times the error. So that sets up the smoothing values. So once we have set these up, then we can copy all of that all the way to the end. Okay, but remember here our our fitting sample is from 68 through 1999. The holdout sample is 2000 to 2006. Let's move this formula out of the way from here. Okay, now let's set up the error measures. Okay, starting from MSE. Okay, so here the actual values starting from the first quarter of 68 going all the way through the last quarter of 1999. Okay, so that's MSE, and in a similar way we can compute these four measures. Okay, now MASE, same two ranges as these, except that the third range will be from year 1967 through 1998. So after the setting up the first two ranges, okay, the third range will be 1967 through 1998 fourth quarter. So that will give us MASE, and same range for TL. Okay, like that. Now we do the same thing for the holdout sample. Okay, holdout sample will go from 2000 to 2006. So first MSE. So we have 2000. The ranges are 2000 quarter 1 through the end 2006. Okay, so that's MSE, and in a similar fashion we can set these three things up. Okay, now MASC, same two ranges as these, except the third range is going to be for year 1999 through 2005. So after setting up the first two ranges, you go to 1999, actual value starting from 1999 through 2005. Okay, so that will give us the AC, and same range for Thiel's U, so like that. So now we have completed the additive model. Now we can run the solver solver. Okay, here we want to minimize. Remember, here solver we must use the fitting sample, not the holdout. Okay, now minimize that, and alpha, beta, gamma should be less than or equal to 1. non-negative GRG, solve, and we get the best model, the best alpha, beta, gamma values. So now we have set up the additive model. So now let's look at the multiplicative model.